Dot dt, vt and at graph. So dt, vt and at graph. So dt graph, vt graph and at graph. So this is d, dt, this is vt and this is at. So this dt graph would be quadratic. Why? Because the position function. This is a second degree polynomial, so it has to be quadratic. If I told you many times, hopefully you remember, if dt is quadratic, vt has to be linear increasing. So it should be linear increasing. But just to make sure, the velocity function is linear increasing. Okay, that proves my point. Velocity function is linear increasing. So let's go draw. You can make sure even more. You need 2 points to draw the velocity versus time. So point 1, you know that 0, 0. Point 2, you kind of know that. This is 1.5. which is the time. Velocity final, you don't know that, but come on, you know that because you have the velocity function. So which is 80 over 3, 3 over 2. So final velocity is 40. So this is 40. So you need 2 points to draw a line. So 1.5 comma 40. Now you connect them. So this is your velocity. This is your velocity. Okay. All right. So if the dt is a curve, vt is a diagonal line. If vt is a diagonal line, at must be what? At must be a horizontal line. But how do you know that? You can check it. Is right here, 80 over 3. So we kind of know the slope of this line, which is 80 over 3. We also know the slope of this line, which is 80 over 3t. So this is the slope, this is the slope. Which is a function of time. And this is 40 over 3 t square. I hope you see the connection, and the connection is embedded in calculus. If you write this function over here, p of t is 40 over 3 t square, then if you take the first derivative, you get 40 over 3, you put 2, t, 2 minus 1. So you get 80 over 3t. If you take the second derivative using the calculus invented by Sir Isaac Newton, you get the exponent is 1, 80 over 3, being done the 1, t, 1 minus 1. So you get 80 over 3. This is called dt. This is called vt. And this is called at. The derivative of pt is velocity, and the derivative of velocity is acceleration. This part you don't need to know now.